Hi, this is Mrs. Basin, and the screencast is a review of determining empirical formulas using combustion analysis. So here's our example problem. We have a carbohydrate, and it tells you that it only contains carbon, hydrogen, and oxygen. Some of these will only contain carbon and hydrogen, and some of the problems will tell you that they only have carbon and hydrogen, but if they don't tell you, just remember it is possible for one of these compounds to only have those two elements. The way you'll know that is if you get to the point where you've calculated carbon and you've calculated hydrogen and you subtract it from the total, you're going to end up with 0, and that's how you would know that that particular compound only has carbon and hydrogen. This one, however, it tells you that you are going to end up with all three. So what we're looking at is it's going to tell us the total of the sample that was combusted. This one also tells us the molecular weight, and we'll need that at the very end. And then the last thing it tells us is how much carbon dioxide and how much water was produced. The CO2 and the H2O is how you're going to know that this is a combustion analysis rather than just a regular empirical formula problem. And what we'll do is use the CO2 amount to get our carbon, the H2O amount to get our hydrogen, and then we can subtract those from our total to go back and get our oxygen. So we're going to start with our CO2. And we have 29.5747 grams of CO2. And we're going to go through and we're going to convert that to grams of carbon. So first step is to convert this to moles of CO2. So for every 1 mole of CO2, there's 44.01 grams of CO2, and that's just the molar mass. That's carbon plus 2 oxygen from the periodic table. And then once we have that, we can use the ratio of carbon atoms to the CO2 molecule to get to carbon. So 1 mole of carbon, there's 1 mole of carbon for every 1 mole of CO2. So in every CO2 molecule, there's 1 carbon. That's where this 1 mole of C comes from. Our final step is to go back to grams, because we're going to eventually have to subtract that from gram amount they gave us in the beginning up here. So for every 1 mole of carbon, there's 12.01 grams. And again, that's the molar mass. So once we go through and do that math, we end up with 8.0707 grams of carbon. Okay, so that's our carbon. Now we're going to look at, let me change colors here. Now we're going to look at hydrogen. So the next thing we're going to look at is our H2O. So our original amount of H2O up here was 12.1068 grams. H2O, and we're going to start out the same way. So we're going to use water to get to just hydrogen by itself. So for every 1 mole of water, the first thing we have to do is change it to moles of water. So we're going to use our molar mass of water, which is 18.02 grams, which again, that's just 2 H's plus 1 O. That's just all the elements added up. Then we're going to go from moles of water to moles of hydrogen. So for every 1 mole of H2O, there are 2 moles of H. And again, that comes from down here. So for every 1 water molecule, there are 2 H's within there. So that's where this 2 moles of H comes from. Last step is to go back to grams. So for every 1 mole of H, 1.01 grams. And so from that, we end up with 1.3571 grams of H. So then, once we've done that, now we can go back and figure out our oxygen. So we're going to look back at our total. So if we go up here to the top, our total again was 10.7695 grams. So that was our total. So we're going to start with that down here. So 10.7695 grams total. Get rid of these marks here. Okay, so that was our total. We're going to subtract out carbon from that. So 8.0707 grams of carbon. And then we're going to subtract out our hydrogen. So then whatever is left is our oxygen. So when we subtract that, we end up with 1.3417 grams. I know that's kind of hard to see. I'll start another sheet here in a second. 1.3417 grams of oxygen. And again, what I did to get to the oxygen was I went back to my total up here. So that was all of the elements together before it was combusted. I took that right here, subtracted out the carbon, subtracted out the hydrogen, so then whatever was left was my oxygen over here. Now remember we said if you get to this point and there isn't any oxygen left, like if this rounds to 0, then you know that that particular substance only has carbon and hydrogen in it. But this particular one, like it told us in the beginning, has carbon, hydrogen, and oxygen. Okay, so I'm going to go to another slide here to do our next step. So now what we're going to do, it's just like a regular empirical formula problem. I have my grams of carbon, so I'm going to start this again with grams of carbon. So I have 8.0701 grams of carbon. And just like before, I'm going to list everything that's here. So I have grams of carbon. I have 1.3571 grams of hydrogen. And then my final value from the previous slide, I had 1.3417 grams of oxygen. So those were my 3 different elements that are in this formula. So I'm going to go back up here to carbon, and now I'm going to convert all 3 of these to moles, and what I'm looking for is the lowest whole number ratio. So 1 mole of carbon, I'm using molar masses again, 12.01 grams of carbon. So from that I get 0.67 0.6720 moles of carbon. Then I go to my next one. So for hydrogen, for every 1 mole of hydrogen, I have 1.01 grams of hydrogen. So for this one I end up with 1.3437 moles of H. And then for my last one, I have oxygen. So for every 1 mole of O, I have 16 grams. So I end up with, and I'm going to move this up a little bit, 0.08386 moles of O. Okay, so these are my mole ratios, but I need to have lowest whole number ratios. So this is the point where I'm going to go through and divide all of these by the smallest. So in this case, my smallest value is my oxygen. So I'm going to divide all of these by oxygen. So 0.08386. I know that's kind of hard to read, but that's the same number right there. And this one divided by the same 0.08386. And again, I chose that one. I chose this one down here because that was my smallest value. I'm dividing all these by the smallest. So then this one again divided by 0.08386. And then what I'm looking for here are 3 numbers that I can round to a whole number. So if it's like 0.1 or 0.9, I can round. In this case, if you get to this point and you end up with like 0.3 or 0.9 for your whole number, then that's when you have to multiply. So if we start down here with oxygen, we know that's going to be 1. Come back up here to carbon. If you divide these 2 numbers here, you end up with 8. And then for hydrogen, when you divide that, you end up with 16. So I have 8, 16, and 1. So what that tells me that my empirical formula is I'm going to write it up at the top here, C8H16. Okay, maybe I'm not going to write it there. Let me write it somewhere else. Okay, so let's go in the middle here. So I end up with C8H16 and O. So that is my empirical formula. Okay, the other piece of information they gave me in the problem was they gave me a molar mass. What that molar mass allows me to do is go from empirical to molecular. So this one here is empirical, EMP. So this is my empirical formula, but to get to molecular, and I'm going to work this through in the middle here, I hope that's not too confusing. I have my X value. X is the molecular weight over the empirical formula weight. So so empirical weight. Or you could say, probably the way, let me get rid of this, probably what we called it in class, we said it was molecular weight over formula weight, FW. Okay, so to get the molecular weight, this top number here, this is the number that's given in the problem. So if you go back a couple of slides, the number that was given was 128.20. Okay, so that was my molecular weight. This was given. Okay, I'm going to divide that by my formula weight, which comes from this over here. So to get the formula weight, I'm going to take 8 C's plus 16 H's plus 1 O. So that comes out to be 128.24. So that was from my empirical formula. That came from over here. So when I divide that, that's obviously going to be 1. So if X equals 1, that just means that my empirical and my molecular are the same. So then this would be my empirical formula, and then it would also be my molecular formula. So again, C8H16O is also my final molecular answer.